There's a place off the coast of Australia that at first glance looks like just another speck of land in an ocean of many, but the more you look, the more it refuses to be understood in conventional geographic terms. What should be simple? Where the island is, how it got there, what it's made of, and why it looks the way it does, turns out to be anything but. This is the story of an island that challenges the very assumptions we make about landscapes, geology, and the forces that shape the world. Most people know Australia as a massive continent surrounded by smaller islands, Tasmania being the most famous. But down near the Southern Sea, etched against crashing waves and swirling currents, lies an island so unusual that scientists, cartographers, and explorers have puzzled over it for decades. Its contours don't match typical tectonic formation patterns, its biological diversity is perplexing, and its very existence seems to defy the continuity we expect from geographic evolution. To understand how strange this island really is, we first need to understand what normal looks like. Most islands are formed by one of a few processes: volcanic activity, where eruptions build land masses above sea level, coral growth over millennia, creating rings of reef that eventually become habitable land, or break-offs from larger continents due to shifting plates. Each of these has a clear, telltale signature in the rock beneath, the soil above, and the life that takes hold over time. But this island doesn't behave like any of them. Its rock composition is unlike the volcanic basalt we associate with oceanic islands. It doesn't show the ringed coral limestone of reef islands. Instead, its geology resembles an ancient continental fragment, something that should be part of a vast landmass, not a solitary outcrop drifting in the sea. Satellite imagery taken over the years confirms something even more curious. The underwater landmass surrounding the island stretches far farther than visible land. Bathymetric studies, maps of the seafloor, reveal plateau-like structures that don't slope into the deep ocean as you would expect. Instead, they extend and connect in patterns that suggest a much larger formation submerged beneath the waves. This has led some geologists to propose that the island is the last remnant of a prehistoric landmass, one that existed before the Australian continent even separated from its Gondwanan ancestors. If this is true, then the island we see today is not an island at all in the traditional sense, but the exposed tip of something far older, older than the continent it sits beside. But geology is only the beginning of the mystery. Biologically, the island hosts ecosystems that are out of sync with its neighbors. Species found nowhere else in Australia thrive here, and yet they don't seem to have clear evolutionary paths from nearby populations. Biologists have cataloged plants and animals on this island that are eerily similar to species found not in Australia, but in regions thousands of miles away, places no species could have reached by normal dispersal routes. As one researcher put it, it's as if the island were a seedbed of ancient life, preserved in isolation, untouched by the patterns that shaped the rest of the continent. Further baffling scientists is the way the island's flora adapts to its climate. Unlike the predictable gradients of vegetation seen on mainland Australia, where arid interior gives way to temperate forests near the coast, this island has abrupt ecological shifts within short distances. A desert-like expanse can be followed by fern-covered valleys, and then tropical pockets of unheard-of abundance. Climatic modeling shows no clear reason for such diversity. Weather systems around the island are remarkably uniform. So how did this happen? One theory suggests the island might have once straddled multiple climatic zones long ago, and as sea levels rose and continents drifted, it became a mosaic of remaining habitats, a relic of an era when global climates were far more varied and interconnected. Another layer of mystery lies beneath the soil. Soil scientists examining core samples taken deep below the island's surface have found elements and mineral deposits that don't match the chemical profile expected of nearby Australian rock formations. Some trace elements align with geological signatures found in parts of Zealandia, a largely submerged continent beneath the Pacific, and even some that resemble fragments from ancient Antarctica. This raises the tantalizing possibility that the island isn't just old. It might be a geologic patchwork, a fragment pulled from multiple ancient plates. If confirmed, That would revolutionize our understanding of how landmasses break apart and reassemble over eons. Then there's the matter of human history on the island. Indigenous peoples have traditional stories and languages that refer to the island in ways that imply it was once part of a larger homeland. Oral histories speak of vast lands swallowed by the sea, of migrations and journeys across waters that once seemed narrower. Early explorers, guided by local narratives, found evidence of ancient habitation in places that have since been submerged. Archaeological studies have uncovered tools, fire pits, and ceremonial structures dating back tens of thousands of years, some older than the earliest known settlements on mainland Australia. These findings suggest that humans might have lived on this land long before sea levels rose to isolate it. But what kind of society could bridge the divide between land and sea in those ancient times? And what does that mean for our understanding of early human migration? The more researchers dig, literally and figuratively, the more questions arise. Even ocean currents around the island don't behave as expected. Typically, large land masses disrupt ocean flow, creating predictable patterns of eddies and upwellings. But current mapping around this island reveals chaotic, almost sculpted streams of water that defy conventional oceanographic models. Some scientists believe that the submerged portions of the landmass interact with tidal forces in ways no one has fully mapped, creating microecosystems and nutrient flows that give rise to the island's unique biodiversity. And speaking of biodiversity, the isolation of this island has made it a proving ground for evolutionary theory. Charles Darwin once imagined islands as natural laboratories, places where species evolve in distinct ways due to isolation. But this island seems to flip that idea on its head. Here, species appear to evolve not just in isolation, but in seeming contradiction to expected evolutionary pathways. Genetic analyses show that some species have markers aligning them with distant relatives in far-removed regions, organisms that could not have reached this island through natural dispersal, at least not without technological assistance or extraordinary chances. This has led to far-reaching hypotheses, some mainstream, others more controversial, about possible ancient seafaring, lost land bridges, and even climatic shifts that once allowed species to migrate across now submerged terrains. If any of this is true, it would upend long-held assumptions about how species spread and adapt across the globe. Then there are the ocean trenches flanking this island. Unlike the steep drop-offs found next to most continental shelves, these trenches have gradual gradients and terrace-like steps. It's as if a larger plateau sunk slowly over time instead of breaking off abruptly. This kind of submersion suggests not a sudden cataclysm, but a measured geological descent, something not fully explained by current tectonic models. Seismic studies show that the crust beneath this island is unusually thick for an oceanic region. Most islands have relatively thin crust that formed through volcanic activity or sedimentary accumulation. But here, the crust is composite, layers of ancient continental rock sitting atop more recent marine deposits. It's a geological anomaly. Of course, not all scientists agree on every interpretation. Some argue that the island's oddities can be explained through known processes, like microplate tectonics, unusual volcanic history, or long-forgotten glacial cycles. But even tentative explanations often require extensions to existing theory, suggesting that while the island may eventually fit into a broader understanding, it currently pushes the boundaries of what we think we know. This island also raises questions about how we define land and sea. The terrestrial marine boundary is usually clear. Land ends at the shoreline, sea begins at the edge of the continent. But for this island, the boundary is blurred. Submerged landforms that should be deep underwater are closer to the surface than expected, and some marine creatures typically found only in deep ocean environments appear at relatively shallow depths nearby. This suggests that ancient connections between land and sea here were far more complex than elsewhere. Culturally, the island has been a crossroads of myth, exploration, and fascination. Indigenous belief systems often treat it as sacred ground, a place that bridges worlds. European explorers who first mapped the region documented strange sightings and unusual tides, writing about the island with both awe and confusion. In recent decades, scientific expeditions have brought satellites, sensors, submersibles, and drones to try to unravel the mysteries, but each new discovery seems to spawn more questions. Some of the most intriguing clues come from paleoclimatology, the study of past climates. Ice cores and sediment layers around the island contain evidence of climatic conditions that suggest a far different atmospheric history from the mainland. Some layers indicate wetter, more temperate conditions at times when mainland Australia was drier. This suggests that the island may have been geographically or climatically distinct for much of its existence, preserving ecosystems that vanished elsewhere. It's on this island, in fact, that researchers have found plant species that appear to have no living relatives anywhere else on Earth. These aren't merely variations. They are lineages so distinct that they challenge conventional classifications. Some have proposed that these species represent evolutionary branches that diverged millions of years ago, long before the rise of familiar Australian flora. Imagine a time when this land was not an island, but part of a sprawling super-terrain, crisscrossed by ancient rivers, lush with life, connected to distant continents. Then imagine that over tens of millions of years, ocean levels rose, plates shifted, climates changed, and all that remained above water was this bewildering fragment. A fragment that today still bears the imprint of that long-lost era. There's a reason scientists return year after year, decade after decade, to this place. It's not just a mystery, it's what the mystery represents, a gap in human understanding about how our planet actually came to be. And perhaps that is the most remarkable thing about this island of contradictions. It insists that we keep asking questions, not just about rocks and species or ocean depths, but about our place in a world far older, far stranger, and far more interconnected than we ever realized. Because when we think we have the world figured out, a place like this appears, unannounced, unexplained, and utterly defiant of expectations. And suddenly we realize how much there still is to learn.